Hello everyone, this is Russell Wilson with exam mini video number 6 and I chose prompt 1. So let's get started. We're looking here at the operon and prokaryotic cell transcription. And so you see we have our promoter region laid out along our DNA strand with the operator and structural genes. Now we know that transcription starts when the RNA polymerase binds to our promoter region, and it is going to continue down the DNA strand through the operator region, and it's going to turn these structural genes into an mRNA strand. So that's what we want, but we might be asking ourselves, does this happen all the time? Is this just going to happen whenever? What controls this? And so let's look at one such instance when it can be controlled. So we're looking at the positive inducible regulation of the transcription. And so it's positive because it uses an activator protein, and it's inducible because it uses a small molecule or an effector. And those two things are going to bind together, the activator protein and the effector, so to make a positive inducible regulation. And so once those two things have bound together, it's going to be looking for the DNA strand. Now it's important to know that transcription will not occur until this activator protein and effector have bound together and bound to the DNA strand. It can sit there all day long without these things, and it will not create an mRNA strand. So once those have bound at our activator DNA binding site, then it's going to initiate our transcription. So those have bound, and we are going to see RNA polymerase come in and go from our promoter region through our operator region. Now, the operator region is where repressive factors can bind to the DNA strand, but when it doesn't see any of those, it's just going to keep on going through there, and it's going to get to our structural genes. Now, these are going to be turned into our mRNA strand, just like we saw in our other slide, and that's what we want. That's great. Now, the important takeaway here is that transcription will not occur unless our activator protein is present. This is kind of similar to when I want to schedule a vacation. Now, I love Walt Disney World. It's my favorite place on earth. It's the happiest place on earth, and so I love to go. But much like the activator protein on a DNA strand, I need a ticket. And much like the small molecule that binds to the activator protein, I need money. You need money for the ticket, you need money to go, you need money for all the snacks and stuff. So you're going to need that ticket, absolutely, and you're going to need that money, yes. So once you have those two things, they can kind of bind to the beginning of your experience planning a Disney trip, and then you get to go down there and you get to see the Disney World. You see the castle and the snacks and the fireworks, and you make memories on with all these things with the rides and everything. So that experience is kind of like your mRNA strand. But remember, you have to have that ticket and you have to have the vacation money, just like your activator and small molecule. Well, I hope you guys have enjoyed this. I've enjoyed making it. Thank you very much.